In this video, we are going to exercise the rule of multiplying powers with the same bases. And that rule, as we remember, is keep the bases the same and add the exponents. In a previous video, I went over the why and the how behind this property. Now, as I said, we're going to practice it. So let's start with letter A. The instructions are to simplify. So we are told that we are to simplify 4 cubed, or 4 to the third, times 4. Now what is 4 to the third times 4? Well, if there's no exponent here, we assume that's to the first power. Any number to the first power is itself. So that simplifies with our rule of keeping the base the same, and then we're adding our exponents, 3 plus 1. So in my head, I'm doing 3 plus 1. I'm not writing that on my paper because I know that 3 plus 1 is 4. Some teachers will want you to just stop here, and some teachers will want you to show that 3 plus 1 work, just so that you can show your thinking. Not a bad practice. 4 to the fourth, other teachers will want you to then simplify that, either with a calculator or, my goodness, doing it out by hand. 4 to the fourth means multiply 4 by itself 4 times. And when you do that, you get 256. And that would be your answer simplified numerically. Here we've got some variables. We have the same bases, so we're going to keep the base, and then we will add the exponents, which is, in this case, 2 plus 5. So you have 2 a's being multiplied, 5 more a's being multiplied, for a total of 7 a's, or a to the 7th. And there's nothing more you can simplify there. Sweet. Okay, letter C. Oh no, we've got 2 variables. What do we do? Just deal with it one chunk of like bases at a time. Here we have x to the 7th times x to the 4th. So we are going to do x to the 7 plus 4 right here. And then in the next piece, we are going to do y to the 5th times y, which is y to the 1st. So y to the 5th times y is y to the 5 plus 1. So you've got times y to the 5 plus 1. And then from there, we simplify those addition pieces in the exponents. 7 plus 4 is 11 times y to the 5 plus 1 is 6. Often we get rid of that little dot multiplication symbol and write it as x to the 11th, y to the 6th. Now, a lot of people make silly addition errors here. If you're making a lot of silly addition errors, I would recommend do show out your addition work and focus on each individual part of thinking that you're doing. So once you get to 7 plus 4, put all your attention on that before you go on to the next step and deal with the y multiplication. It's good stuff. Now, one other thing to point out, the bases are different here, which is why we don't get xy to the 17th, right? When the bases are different, as I showed in a previous video, you cannot combine those numbers, those values. Okay, so here, oh no, we've got coefficients, numbers involved. So there's this thing called the commutative property of multiplication that allows us to multiply in any order we like. And since this is all multiplication, right, there's technically negative 7 times y to the 3rd, negative 8 times y to the 12th, we can reorganize this. I usually do this mentally, but here's what's going on in my brain. I reorganize everything so the variables are multiplied together and the coefficients are multiplied together like so. Now that we've got that squared away, I do negative 7 times negative 8, which is positive 56. And let me tail off that 6, there we go. And then y cubed times y to the 12th. In my head, I'm doing y to the 3 plus 12. So I'll kind of put that off here. This is what's going on in my brain, right here. And y to the 3 plus 12 is y to the 15. And that, my friends, is your answer. I don't know why I circled that one, but not the others, but I did. So anyway, here we go. The final problem here, you've got 5m to the 6th times 12m cubed. Again, I'm going to reorganize everything, and I usually do that mentally, but going on in my head is this process where I reorganize with the commutative property, a multiplication. So the variables are multiplied directly right next to each other, as well as the coefficients. 5 times 12 is 60. Now at this point in time, you got to focus on what you're doing here. Some people will write that as 17 because they're in this mode where they're adding things. You are adding exponents to say how many times like bases are multiplied. Here we're simply multiplying numbers that are already in bases. M to the 6th times m to the 3rd. In my head, I'm doing m to the 6 plus 3. That's what's going on in my head for this problem, which is m to the 9th, and that is my final answer. There you have it, folks. Several examples of how to use your multiplying powers with like bases rules. It's good stuff.